Of inequalities word problems. So to start off for today, we're going to review how to identify an inequality in a word problem. So it says Adrian works in New York City and makes $42 per hour. She works in an office and must get her suit dry cleaned every day for $75. If she wants to make more than $260 a day, at least how many hours must she work? So I underlined some keywords in this question. When we see things like wants to make more than a certain amount or at least how many hours, we know that we're working with inequalities. If it said something like wants to make exactly 260 or how many hours exactly, that's a sign you're working with equations. All right, so you want to make sure you underline these keywords in our word problems anytime we see them, because we want to make sure that we're addressing the inequality part. So, just for the sake of this question, how do we figure this out? Well, first we need to identify our variable like we always do. So, we're looking for how many hours she must work. So, let H equal number of hours of work. Right? So, how much money does she make? Well, she makes $42 times the number of hours. But she needs to dry clean her stuff every day for $75. So when I dry clean, that means I'm paying out my money. I'm losing $75. So I'm going to subtract 75 from this amount. So now we want this entire value, right, the amount of money she makes, to be more than 260. Okay? That means it has to be greater than or equal to $260. Okay, so we want that whole value to be more than. Okay, so we're going to be using those same types of keywords to apply to systems, meaning we have two or more inequalities within a single question. So we're not going to worry so much about solving this. I really want to focus on the setup. Okay, how do we do that? So let's look at some examples. You can work at most 20 hours next week. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays you $7.50 per hour, and your job as a car wash attendant pays you $6 per hour. Write a system of linear inequalities to model the situation. Well, what is the first thing we always do when we're working with word problems? We have to define our variables. So what are the two unknowns? Well, you have two different jobs where you'll work two different amounts. So each one of those jobs needs a separate variable. So let's let D equal hours dog walking. And let's let C equals hours car wash. Right? So those are the hours you work dog walking versus the hours you work at the car wash. So now let's see what is the relationship. Well, we have two relationships. We have that we need to work at most 20 hours. And we need to earn at least $92 from these two jobs. Okay? So let's start with the money equation. If I make $7.50 per hour dog walking, we can represent that mathematically as $7.50 times D. In order to find out the total amount of money I'm making, I have to add to that the amount at the car wash. So that's $6 times the hours at the car wash, right? So now that is the total amount of money that I'm making. I want that to be at least 92. Well, at least 92 means that I'm making 92, 93, 100, 200, more than 92. So we're going to have a greater than or equal to 92. Okay, so that's my money equation. The second equation I'm working at are the hours themselves. I want to work at most 20 hours. Well, what are the hours that I have? Well, the hours dog walking plus the hours at the car wash, and it cannot be more than 20 hours. So that means I could have 19, 18, 17, anything less than or equal to 20 hours. Okay, so the system of inequalities that I'm working with here is that right there. Okay, let's try another one. Marcia is buying plants and soil for her garden. The soil costs $4 per bag and the plants cost $10 each. She wants to buy at least 5 plants and can spend no more than $100. Write a system of linear inequalities to model the situation. Well, let's see what we have here. We want at least 5 plants, no more than $100. Okay, so let's start with the money equation. What are my variables? Well, P will be the number of plants that I buy, and S is going to be number of soil bags that I buy. Okay, so if I look at the money equation, it's $4 times the number of soil plus $10 times the number of plants can be no more than 100, which means it can be anything less than or equal to 100. So that is my money equation. So now what are the restrictions on my purchases? Well, she wants to buy at least 5 plants. It does not say anything about soil. So the only restriction I'm going to have is that my plants have to be at least 5. So I can have 5 plants, 6 plants, 7 plants, anything greater than or equal to the plants. There is no restriction on soil. So it is not included in that. And we can have that, right? That's still a system. We still have 2 inequalities, right? We just know that this P is either going to be a horizontal or vertical line depending on how I set up my graph. So speaking of graphing, let's try one. So we have an online electronics store that must sell at least $2,500 worth of printers and computers per day. Each printer costs $50, each computer costs $500. The store can ship a maximum of 15 items per day. Part A. On the set of axes below, graph a system of inequalities that models these constraints. Okay, so we need a system to be able to graph a system. So we want to first define our variables. But since our graph is already listed, we have one thing we have to pay attention to. My printers are going to be on my x-axis. So it might even be easier to let x equal the number of printers. So when I graph it makes my life a little bit easier. And my computers is on my y-axis. So my y is going to be equal to the number of computers. Okay, so what are my 2 restrictions? Well, we have a money restriction and we have an items restriction. So my printer costs $50, my computer costs $500, and we want to sell at least $2,500. So $50 times my printers plus $500 times my computers. Oops. That has to be at least, which means it has to be greater than or equal to $2,500. Great. Now the store can ship a maximum of 15 items per day, meaning 15 is the biggest amount of things I can ship. So X plus Y is everything I'm going to be shipping, and that has to be less than or equal to 15 items. Right? It has to be less than 15. We don't have the space for anything more than. So now we could graph this using our calculators, but I'm going to teach you a little trick for quick graphing. When we have big numbers like this, and we're concentrated in our positive quadrant, we can quick graph using our X and Y intercepts. This allows me to see the biggest number that I need on my x-axis and y-axis. It can help me set my scale. So I'm going to identify my x and y intercepts by plugging in 0 into the inequalities. So if I'm looking at 50x plus 500y greater than or equal to 2500, my x-intercept will be the result of this little equation because y will be substituted in for 0 and disappear. And we get x is equal to 50. And my y-intercept is the opposite, right? I plug in 0 for x, so I get 500 is equal to 25. And I divide. Y is equal to 5. So my x-intercept for this inequality is 50. My y-intercept is 5. Let's look at the other equation. X plus y greater than or equal to 15. So this is a little bit easier. If I substitute 0 for y, my x-intercept will be 15. If I substitute 0 for x, my y is going to be equal to 15. So what do I know about my axis? Well, I know that I have to be able to fit at least 50 on my x-axis and 15 on my y-axis. So I'm allowed to use two different scales, so I will be using two different scales. There are 20 boxes by 20 boxes. If I divide 50 by 20, right, that means I need at least 2.5 boxes, 2.5 units per box. So I'm just going to round up to a nice even number, and I'm going to say 5. That will definitely fit everything that I need. I could have went to 3 if I really wanted to, but I'm going to stick with 5 because most of my numbers are divisible by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. Okay. On my y-axis, the biggest number is 15. There's 20 boxes I can go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, there were 17 boxes, not 20. Sorry. Okay. So now let's plot the x and y intercepts so that I can start graphing. So for this first equation, my y is 5. 1, 2, 3, 4, 5. Y-intercept. And my x-intercept is 50. If I connect those two, and if I use a straight edge, it'll be much more accurate. I have a rough sketch of that equation. Now, I can plug it into my calculator by solving for y and getting exact values and on a region, so that's what you want to do. But for a quick sketch on the homework, the intercept method is sufficient. So now where do I want to shade? Well, this is a greater than or equal to, which means I'm shading above. So everything I shade is going to be above this line. So I'm going to do that. Shade, shade, shade. All right. Okay, so now let's take a look at the second inequality. Let's do green. My x-intercept is 15. My y-intercept is 15. If I connect those two things with the straight edge, it'll be a much more accurate point. And now, again, we can find this point of intersection by plugging into our calculator. And when you have a lot of time, you can do that. All right, but I'm going to do my quick sketch. Now, this is a less than or equal to, so that means I'm going shading below this. So I'm actually going to use a smaller shade, and I'm going to shade everything in here. So where is my solution area? Well, it's the overlapping section right here. So that's the area I'm going to be concentrated for my answer. So let's take a look at part B. Determine a combination of printers and computers that will allow the electronics store to meet all of the constraints. So what I want to do is I want to pick a value that's clearly in this range and show that it works. So let's see. Well, 5 is clearly going to be in this range. And let's say 5, 7. That's a point that's directly in the middle. There's no question about it. So let's say we can get 5 printers and 7 computers. We want to explain how we get our answers because this combination is in the shaded area.